Hello, I'm Maika and welcome to the Tinkercad microcontroller tutorial where we'll be simulating using our Arduino with different types of LEDs. This material is made for Tinkercad but can be applied to a physical breadboarded circuit and a physical Arduino as well. This is part of a series of electronics workshops made by the electronic Artrium. Before we start with the actual electronics portion, if you don't have a Tinkercad account already, sign up for an account. Logging in should take you directly to the dashboard. There are multiple different types of designs you can make on Tinkercad, like 3D designs and code blocks. But for our workshop today, you'll go down to the circuits category to be able to create your first circuits design. When you first create a new design, the Components tab in the top right will likely show just basic components. Switch from basic to all to be able to see all the types of components that are available to simulate using this website. Once you do this, your sidebar should look very similar to the screenshot all the way to the right. Take a brief moment to scroll through the different types of components you can choose to familiarize yourself with what's available, especially if you'd like to come back to this website at a later date to create your own personal project. The first thing we'll add to our design is a breadboard. You're welcome to choose any of the three options, but for mine, I'm using the regular full-size breadboard. While breadboards may have been explained in a different video or you have some knowledge from past experience, I'll go over it again as a refresher. In the process of fabricating a circuit, it's most optimal to use a breadboard in the prototyping stage, since it's easy to rapidly create different designs. This is why a breadboard may also be called a protoboard. When we say breadboard, it's widely assumed to be a solderless breadboard, but there's also solderable breadboards available as well. As for more information about the breadboard, the two rows at the top and the two rows at the bottom are the power rails. The rails are horizontally continuous. There should be a rail indicated by the plus sign and a rail indicated by the minus sign in each pair of power rails. Make sure you pay attention to this when connecting a component that supplies or receives power, as there are some components where reversing the polarity can be detrimental and break the component entirely, although this isn't a worry at the moment since we're simulating a breadboarded circuit online. This is more for if you decide to take any of the designs you see today or any other schematics and breadboard them physically, because I've definitely blown up a few LEDs in the past by accidentally reversing the polarity when first starting with making circuits. Another thing to look out for, particularly with these longer breadboards, is that the lines going along the power rails that are also typically blue and red to correspond to the polarities aren't split halfway like in the image in the top right. This usually indicates that the metal receptacles inside aren't connected all the way through. This allows you to use two different voltages on the same breadboard, like if you need 5 volts for one component and 3.3 volts for another component. But be careful in assuming that the entire rail is always continuous. If needed, you can use a jumper cable to bridge the two halves. This isn't a worry for the digital breadboard today, but it's important to know. The rows in the middle of the breadboard are connected vertically, if viewing the breadboard with the power rails on the top and the bottom. The rows are connected halfway across the board, not in the groove across in the middle of the board, as seen in the image with the fully highlighted green rows and power rails in the bottom right. Tinkercad makes remembering these easy, as hovering over a hole shows which other holes are electrically connected to that one. Your Arduino to the project. There should only be one option available in this simulation, namely the Arduino Uno R3, but there are many different types of Arduinos available, and if you ever want to convert one of these simulated projects to a physical Arduino project, you should investigate and pick the type of Arduino that best suits your needs. You could also look into a different type of microcontroller entirely, like a Raspberry Pi. There are a variety at different price points. Many of these boards have different components available already on the board itself, removing hassle in some cases for certain projects. If you're ever curious what a board does, check out the documentation available for a full list of details. The Arduino Uno is just the basic standard microcontroller, but with plenty of capabilities on its own and pins available, which is likely why it was chosen to be the type of microcontroller available on Tinkercad, and it's what we're using today. The two main parts then, we're going to start with a quick introduction to the coding environment in the Tinkercad simulator. You'll notice that when you press code in the top right corner, that you'll get the option to use either blocks, blocks and text, or just text. I highly recommend learning how to use the text format even if you're a complete beginner to code, as when you use a physical Arduino, which is generally the end goal here, the IDE, or Integrated Development Environment, where you write your code is entirely done through programming with text. However, if you're trying to teach a younger audience how to code, the block format works just fine to understand code through a more visual lens. For the purposes of this tutorial, the code that we'll be using will be very simple and assumes you have at least a beginner background in coding. Arduino's programming language is based on C++, but is more simplified, so you should be able to follow along with this tutorial if you have knowledge in at least one programming language. With that being said, you should use online resources for clarification if you're unsure what a certain piece of code is doing. The Arduino docs will be a perfect place to look in this case. To the actual tutorial, we're going to start super simple with blinking the LED that is built into the Arduino itself. Aside from the on-off light present to the right of the board, there's also a light to the left of the board that can be blinked manually using code. You may have to zoom in if you're unable to see the LED clearly, or zoom out. The setup for this is simple, where we just set the pin mode of the LED. The pin mode function defines the behavior of the specified pin. Usually the first parameter is a number, the LED underscore built-in is a constant for the pin number of the built-in LED, so we use that instead. The mode can either be input or output, and intuitively, since we're outputting a value to the LED for it to turn on or off, we set it to the output mode. There's also a third option of input using internal pull-up resistors, but we won't worry about that mode here. The loop function is also simple. The pin we are using is a digital pin, meaning that the system either registers the output as one of two things, either high or low. The alternative is analog, where there's a whole range of values available. The LED is active high, where high means on and low means off. Not all components are like this, as some can be active low where the opposite is true. You should always double check this to ensure your outputs or inputs aren't inverted for that specific component's needs. So, this loop basically just turns the LED on, waits for 1000 milliseconds, then turns the LED off before waiting another 1000 milliseconds. This will constantly loop until different code is compiled and put on the Arduino. By clicking Start Simulation in the top right, you should be able to see the LED blink on and off. At the built-in LED, the code used to blink an external LED is very similar. We have the same setup code to set the pin mode to digital and the same loop code. The only difference is that now, we can choose the pin number based on what's available on the Arduino. This is where the breadboard comes into play, since that's where one or more LEDs can be plugged in and then be controlled by the Arduino. Some pins on the Arduino send out a flat voltage or are a ground pin, while some are data pins. Right now, the only specification is that the positive end of the LED should plug into a digital data pin. So using the Uno's pinout diagram, we can see which pins we are restricted to, as well as looking at the Arduino itself and seeing which pins are labeled digital PWM. Now, try adding 3 LEDs to the breadboard. Ensure that the positive and negative pin legs aren't electrically connected to each other by being in the same row. You also don't want the LEDs to be connected to each other, since we want to be able to control all 3 of them individually. As you might notice while you're doing this, the cathode and anode are labeled for you when you hover over the pins, for at least one side, so from a cathode to the Arduino's ground pin, or from the anode to a digital pin at a resistor. The cathode is the negative pin leg, and the anode is the positive pin leg. You can click on the placed resistor and change its value as well. You want the value to be 275 ohms, and if the default is set to kilo ohms, you may have to use the drop-down to switch to ohms. Otherwise, there's too much current going into the LED, which could reduce the lifetime of the LED or cause it to pop and break. To quickly go over why I got 275 for the resistance value, we use Ohm's law of V equals IR, or voltage equals current times resistance, and rearranged it to get resistance equals voltage divided by current. We want at most 20 milliamps going through the LED, so we plug in 5 volts for the voltage and 0.02 amps for the current, getting 5 divided by 0.02, which is 250. To be a bit more on the safe side, I increased the resistance value by 25, getting 275. The bottom of the slide shows an example of how a single LED has been wired, if that helps. If you'd like to try on your own, pause the video now and keep working on it if you haven't already. Means that you should end up with a breadboard like this, where they can all share a common ground using the negative power rail, but the positive pin leg corresponds to a different pin on the Arduino. The different pins should each have a number associated with it, which is its pin number that we're going to use in the code. Hovering over the pin itself should tell you what the pin number is if it's difficult to tell just from the image. Again, this is an example breadboard, but yours doesn't have to look exactly like this as long as you keep what I said in mind about having the ground applied to the cathode of all 3 LEDs, having a resistor, and having that resistor be the right value. And now we can write code to blink the 3 LEDs. The code I have blinks the LEDs all at once, but you could add delay statements in between each LED turning on, create a gradient effect where each LED turns on one at a time, also seen on the slide. Again, notice that the pin numbers I have in the code correspond to the pins that my LEDs are plugged into. The pin number should also match up with the pins you plug your LEDs into. There are a variety of different patterns you can make, and you can add more LEDs if you'd like as well. Here, the code on the left turns the LEDs on and off from left to right, while the code on the right turns on and turns off all 3 LEDs simultaneously. There are a multitude of different things you can do with Arduinos and the components compatible with it, but I want to work with just LEDs for this part of the workshop, so I'll move on to controlling LEDs using a code library that is available to use with LEDs. Individually adjustable LEDs are exactly how they sound and are strips of LEDs, where each LED can be controlled. The library is particularly used to create cool effects, which we'll look into in the next few slides. You can either create a new project or work off the project you have already been creating. It doesn't particularly make a difference, except for if you wanted to keep the previous project or not. If you do, go back to the main Tinkercad homepage dashboard and create a new circuits project like we did at the beginning. On top of adding the LED and Arduino backend, choose and add a NeoPixel strip of LEDs. You should see different variations, and you can choose whichever one you'd like. I just chose to use the version with 10 LEDs just because. To use this LED, we'll have to include the library in the code. You can either type out #include Adafruit neopixel.h or go to the Library tab and click on the NeoPixel library and click on the Include button. It'd be a good idea to pause this video and go to the Adafruit NeoPixel GitHub repository to read a full list of its features and capabilities. We can build our circuit now. The LED strip has 3 separate pins that need to be plugged in. One is a data pin, which should correspond to one of the Arduino digital data pins that hasn't been used yet. One is a 5-volt pin, which should be connected to an external power supply that can supply 5 volts consistently, and one is a ground pin, which can be connected to any source of ground. For the external power supply, we're using a multimeter set to a voltage of 5 volts. Since we have 2 ground sources now, they're connected together where the capacitor pin is. There should be a resistor between the data pin on the Arduino and the data pin on the LED strip. A new component here is the capacitor, which stores energy from the multimeter, essentially acting as a filter in the circuit to prevent the LED strip from being damaged, since if we were building the circuit physically, it would be much more costly to break one of these NeoPixel strips than it would be to replace a single LED on its own. You can see I modified the most basic version of example code present on the Adafruit NeoPixel GitHub repository, where the LEDs are turned red, then green, then blue, sequentially from left to right. The color is cleared after every full color change. Pause the video, go to the Artrium Electronics Workshop GitHub repository, then download Arduino NeoPixel LED tutorial.ino. Copy and paste the code into the Tinkercad simulator and modify it if you'd like. The only part that must be modified in this case is the number of pixels constant at the top, unless you also chose to use 10 pixel strip as well. This library offers many functions and has additional, more complex examples available on their GitHub that I mentioned before as well. This code just tests for basic functionality. The end of this portion of the workshop. If you're looking for more projects you can do with an Arduino or any other microcontroller, there's many sites like Arduino Project Hub that have user-generated projects available. While I can't say all of the tutorials or projects themselves are going to be easy to understand and beginner-friendly, there's many that are definitely worth checking out if you're interested. Tinkercad itself also has a variety of projects available in the Starter section for the simulator, from where we first selected our components throughout the tutorial video, if you'd like to check that out now.